All right, we're going to look at series again. So if you have a series where a bunch of terms are being added up in that sequence, you're going to get a sum. And if that sum exists as a real number, then we say it's convergent. If that sum that you get is anything else, then we know it's going to be divergent. So if it adds up to some real number sum, then you get a convergent series. We're going to look at some today that look like this. So is this a geometric series that we looked at previously? Nope, this is not a geometric series. So what we're going to have to do on this one is separate it. And what we're going to do to separate that would be to use partial fractions. So we've done this before. We're going to say that 1 over n times n plus 2 could be separated as two fractions with n and n plus 2 as its denominator with some constants a and b here. So what we want to do is figure out what those a and b are going to be. So if we were to do the multiplying on here, what we would get is that this would end up being a times n plus 2 in the numerator plus b times n if we multiplied by the opposite ones to get the common denominator, should equal our numerator on the left side here, which is 1. So we're going to pick strategic values for a and b here to figure out what those are. One nice value here would be if n equals 0. Then we could figure out what b is, or sorry, what a I think is pretty easily here. So if n were to equal 0, what we're going to get on the right side there would be that 2a would be, the other one would just be 0, would equal 1. And so we would get the result that a is positive 1/2. Another strategic one here would be -2. If n is -2, then that value of a is going to be 0. And so what this would end up being is -2b being equal to 1. Well, then we know b is going to be -1/2. And so now we got our a and b values that should work here. So what we're going to do next then is now that we have these values up here that we just found out that if we do our partial fractions here and solve, we end up getting that a is 1/2 and b is -1/2. Now we're going to look at what happens when we write this back out. Well, now this would be the same as right here, these two terms, with this being our a and b value. And remember, our b value, or sorry, our a value came out to be 1/2 and our b value came out to be -1/2. So what they've done here is, since we have 1/2 in both of these, they just wrote that 1/2 out here and factored it out, leaving just 1 and -1 as those two terms. So it ends up being 1 there plus, or sorry, -1 over n plus 2. So that's where that 1/2 out there came from. So these two things are equivalent. So what if we write out these terms now, starting with n equals 1? What would we get? Well, we're going to have that 1/2. And then what we're going to have here is putting 1 in there. That'd be 1 over 1, or 1, minus, if we put 1 in that second one, 1 plus 2 is 3, so -1/3. Okay, now we're adding, so our next terms, if we put 2 in now, would be 1/2, and if we put 2 in the second one, it'd be -1/4. All right, plus, now we're going to the next one, so if we put 3 in, we'd put 1/3 -1/5. If we do the next one, we'd end up with 1/4 -1/6. Let's do one more. If we do the next one, we get 1/5 -1/7. And this would continue on. Now, what you notice here, or what you can kind of see if we start simplifying, is that a lot of these fractions are going to cancel out. meaning I see minus 1/3 here and positive 1/3 here. I see minus a fourth here, positive fourth here. Fifth, fifth. There should be something that cancels out these other terms as we keep going as well. So all that's what we're going to see here is that the only terms left are this one, and then at the end of this, um, once all those fractions are canceled, there should be uh, the first two, that 1 and 1/2, and then the last two terms in this would also be left over because they wouldn't cancel out. So we would end up that this would equal our, we get this 1/2 here, so that's our 1/2 here. We also had that 1 and the 1/2 that we saw in the previous slide that were still left. Plus there'd be two terms at the end that would not cancel out either, because those would be the last two subtraction ones. So what is this going to be? Well, now we can figure out this answer by taking the limit of this as we go to infinity. So what's the limit as n goes to infinity of 1/2 times this? Well, we know if we did the limit as we go to infinity here that this would end up being, or these last two would both end up just being 0. Both of those would approach 0. So it looks like this whole thing is going to end up being what's 1/2 times 1 plus a half is going to be 3/2. So it looks like our final answer here would be 3/4. All the numbers in this series should add up to 3/4 as you go to infinity. All right, let's try one more of those where you'd have to use partial fractions. So show that this series is convergent and find its sum. So again, this is one we're going to have to do partial fractions on. So why don't you pause the video and try writing this out as a partial fraction, and then hit play, and we'll try to finish this one off. All right, let's check your partial fractions out. So if you split it up into these two terms, then we should end up with that this is true. Our two easy values here would be using 0 or -1. So we find out that it looks like A equals 1, B equals -1. So if you put those values of 1 and -1 back in for A and B, that should be true. Or that means if we write this back out as our summation, that our original problem should be the same as 1 over n, and then I change that to minus 1 over n plus 1. All right, so let's see now what this is convergent here. Let's write out the terms that we would get for this one. So our first term would be, if we were to write this out, 1. If we put 1 in there, minus, if we put 1 in there, that'd be minus a half. All right, if we put 2 in, we get 1/2. Minus a third. If we put 3 in, we get 1/3 minus a fourth. And you can see again, a lot of every consecutive term here is going to cancel. So if we did this out to the end here, that we would get 1 over n minus 1 over n. And then the next term would be 1 over n minus 1 over n plus 1. And so there should be one that cancels with this. The one prior would cancel with this. Our 1 over n's cancel. So the only one that's not going to cancel there is our minus 1 over n plus 1. So this whole thing is going to end up being 1 minus 1 over n plus 1. So what is this going to end up equaling then for the sum? Take the limit of this and see. Well, the limit of this is going to be 1 plus, this last term is going to approach 0, so this should be convergent. And the sum would be 1.